Okay, this is the Cambridge Lower Secondary Checkpoint exam from April 2023. It's a 1 hour paper and there's no calculators allowed. So this is paper 1. So a regular polygon has 8 lines of symmetry. So a regular polygon would be a shape where all of the sides would be the same length and all of the angles would be the same size. So tick to show these facts about the polygon are true, false, or you cannot tell. So the polygon has 16 sides. Well, if it's a 16-sided polygon, and it was a regular polygon, it would actually have it would have 16 lines of symmetry, okay, rather than having 8 lines of symmetry. So that would be false. All right. The polygon has rotational symmetry of order 8. Yeah, that would be true. Okay, so this thing could spin around and fit onto itself 8 times. So as it tick, 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 tick around 8 times, it would fit onto itself. Okay, just tick the boxes and move on. All right, Carlos, right, rolls a fair 6-sided die 60 times. How many times should he expect to roll a 3? Okay, just expect, not actually necessarily get the 3. Now there are 6 sides on the dice. Okay, so there's a 1 in 6 chance of landing on each of the numbers. 1 is as likely as 2 is as likely as 3. All of them are 1 number out of 6. Okay, so it's 1/6 of the time, and we're doing that 60 times. 1/6 of the 60 times. And so that would be 10 times we would expect to see a 3. We'd also expect to see a 2 10 times, a 1 10 times, etc., etc. Okay. Write the letter for each calculation in the correct column of the table. So either they're equal to 7 to the power of 6, or they're not equal to 7 to the power of 6. Now, 7 times 6, that's nothing to do with powers, that's 42, okay? It's not going to be the same as 7 to the power of 6. 7 to the power of 6 is a huge number. It's 7 times 7 times 7 times 7 times 7 times 7, okay? So 7 times 6 is not equal to 7 to the 6, and that one's already been filled in for us, okay? We've done it. Tick them off as you go through. 7 to the power of 5 times by 7. Now, if there's not a power on here, it's a power of 1. If it's not on, it's a 1, okay? So that's 7 to the power of 6. Okay, so B would work. The reason that it's 7 to the power of 6 is because you add the powers. Okay, when you're doing your multiplication law, you add the powers. When you're doing your division law, you subtract the powers. And in this case, that would be 6 take away 0, which is 6, and so you'll get 7 to the power of 6 there. Multiplication law is to add the powers if you've got the same bases, they've got to be 7s, and the division law is to subtract the powers if you've got the same bases. So C works there. All right, and here the multiplication law would give us 7 to the power of 2 plus 3, which is 5. 2 plus 3 is 5, and so therefore that is not equal to 7 to the power of 6. It's equal to 7 to the power of 5. All right, next up. Question 4 says, expand and simplify. So this is C plus 4, lots of C plus 10. Now, I teach this by doing C times by C plus 10 and 4, lots of C plus 10. So we have C and 4, lots of C plus 10. So it's just splitting the first bracket and placing the second bracket in. I call it split and place, but you might have seen all sorts of different methods, FOIL or grid method or something like that. They're all great, they all work absolutely fine. Use whichever one you've seen most often. Now, we're going to do a multiplication here and a multiplication here. So this will be C times C. C times C is called C squared. C times 10 is plus 10C. 4 times C would be plus 4C. And 4 times 10 would be 40. These, the 10C and the 4C, they add up to 14C. So you get C squared plus 14C plus 40. Okay, nice and simple. All right, draw a line to match each calculation to its answer. 0.5 divided by 10 to the power of 2 is 0.005. Okay, fine. 5 times 10 to the negative 3, that is the same as 5 times 10 cubed. Okay, this negative power gives us a flip, it gives us 1 over 10 cubed, and the division also use keep switch flip, so it's a flip and a flip back is what's going on there. So you're ending up with 5 times 10 cubed. 5 times 10 cubed will be 5,000. 0.05 times 10 to the power of 4, so start with 0.05. We're going to multiply by 10 to the power of 4, so times 10, times 10, times 10, and 10 again. You're going to end up with 500 there. Okay, and by process of elimination, it should be this one, but you should always just double check. 5 times 10 to the negative 1, multiplying by 10 to the negative 1 is 5 times by 1/10, okay, which is 0.5, because that would be 5 over 10, which is a half, which is 0.5, okay. There's a few different ways to do those, but that's the way that I would go with it. Next, work out the value of 10 take away 2 to the 10 take away 2x to the power of 4 when x equals 4. So start by substituting in that x equals 4. Place it in correctly. Now, V is for brackets. We follow the brackets first. So we're going to do 10 take away 2 times 4 is 8. So within those brackets, you need to follow BODMAS or BIDMAS, whichever one you use. So in there, I'm going to do the multiplication first. 10 take away 8 is 2. 2 to the power of 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16 there. Okay, just substitute it in and then follow BODMAS carefully, or BIDMAS carefully. A pyramid has a square base with a side length of 10 centimeters and 4 congruent, so congruent means that they're all identical to each other, triangle faces with each of a height of 12 centimeters. So the parts that are making up the surface area of this pyramid are a square, that's a base, that's 10 by 10, and 4 triangles, and those triangles have a base of 10 and a height of 12. Okay, so first off, the area of the square is 100. Okay, 10 times 10 is 100. Now for the triangle, we're going to do 10 times 12, but we remember to halve it. You remember to multiply the perpendiculars with the triangle, multiply the things that hit at a right angle, and then remember to divide by 2. So it's going to be plus 5 times by, well, 12 times 10 is 120, you halve that to get 60. So each of those triangles would have an area of 60 centimeters squared. 4 times 60 is 240. Add your 100, and you're going to end up with 340 centimeters squared, which needs to go onto the line. Okay, nothing too scary. The surface area is the area of each of the surfaces added up. All right, the arrow points to a number. Draw a ring around the number that the arrow points to. Okay, so it's somewhere between 5 and 6. Now, 5 is root 25. 6 is root 36. So it's somewhere in between those. So it can't be that one and it can't be that one. Okay, so it's somewhere in between them. Root 35 you would expect to see somewhere closer up here. Root 30 looks much more likely, okay, because it's roughly halfway between 25 and 36. Okay, root 35 will be too close to root 36 for that to be right. Just draw a ring around the correct one. Ahmed draws this graph to show the number of visitors, how the number of visitors to his town has increased. So he says there is a big increase in number of visitors to the town. So there's the title. There's the number of visitors. Here's some sort of weird graph. Okay, give one reason why it could be misleading. One could be the title says what it says. You know, it's leading you one way. But another way is that there is no frequencies, okay, or the graph is thick and then it goes thin, something like that, okay. Some sort of, this is not a great graph from Ahmed, unfortunately. Never mind, Ahmed, try again. But there's lots of reasons why this could be misleading, and the most key one is probably the fact that this is not just a line. It's like thicker and then thinner. It's very strange. All right, question 10. 1 over n is equivalent to a recurring decimal. So a recurring decimal is like 0.343434 or 1.2222222 or 12.3555555. Okay, n is a whole number. Safia says n must be greater than 5. Write a number to complete this sentence. Safia is not correct because the value of n could be 3. And that's because 1 over 3 is 0.3 recurring. Okay, so if n was 3, you get 0.3333333, which is a recurring decimal. Okay, n has to be a whole number, so she was nearly right. 1 over 1 works. 1 over 2, yeah, that's 0.5. 1 over 4 is 0.25. 1 over 5, fine. And 1/6 is recurring, but she was wrong about this one. She missed that one out, unfortunately. Write 70,000 in standard form. First, it's got to be 7 times 10 to the power of something. With standard form, you never use the tens column. You should only ever use the units column, and it should have a number that's not a 0 in there. Okay, writing that in standard form, 1, 2, 3, 4. 7 times 10 to the power of 4. Nice and easy. It won't be 7 times 10 to the power of negative 4. That's reserved for small numbers. And big numbers should have positive powers. 7.5 times 10 to the negative 3. Start with your 7.5. It's 10 to the negative 3, so it's going to be a small number. We're going to go back 1, 2, 3 jumps. Divide by 10, divide by 10, and divide by 10 is what's happening there. Fill in your blanks with zeros, and you'll end up with 0.0075. Okay, nice and easy. Next up. All right. Here is Eva's method for drawing the perpendicular bisector of A, B. She draws an arc of radius 5 centimeters from center A. She draws an arc of radius 6 centimeters from center B. She draws a line to connect the points where her arcs intersect. Cool. Now what she does produce is this line here, which is perpendicular, but it's not a bisector. A bisector would cut it in half. Explain why it's not correct. She should have the same arc radius. She should have the same arc radius from A and B. Okay, the fact that she's changed it means that we don't get a bisector. We get something that's slightly over. All right, next. Here is a formula. Draw a ring around the correct rearrangement of the formula. Start by saying what's happened to W. W is subtraction by 2, and then it gets square rooted, and that produces Y. Work backwards. Y needs to get squared, so raised to the power of 2, and then we need to add 2, and that's going to produce W. All right, so it's going to be Y squared plus 2 is going to equal W, and so that is the correct rearrangement there. Okay, Y squared plus 2 equals W. Making sure you remember to put the W equals if you're asked to do this without, the circling thing. All right, next. Write down the value of 7/3 times 5 times 3/7. Call that 5 over 1 would make this a bit easier. So you're doing 7 times 5 times 3 over 3 times 1 times 7. Now, some of these parts will cancel out. They only cancel out when you're doing multiplications. So in the end, you end up with 5. Okay. Another thing to spot is that 7/3 times by 3/7 would be 21 over 21, which is 1. Okay. And 1 times 5 is still 5. 5 is your result there. All right. Calculate 9/10 divided by 2 2/5. You can't do this until you've got improper fraction. So we're going to start with 9/10 divided by. The phrase I use for this is big times bottom plus top. You've got 2 times 5 is 10 plus 2, 12. There are 12 fifths. There are 10 fifths found in 2 wholes, and then 2 fifths found in 2 fifths. So you end up with 12 fifths in total. Once you've got that, we can go with key switch flip. 9/10 times by 5/12, which is going to be 45 over 120. Now we just need to try to simplify that. I'm going to divide by 5. Get 9 over 24, divide by 3 to get 3 over 8. And you might take a little bit of time to get there with your divisions, but 3/8 is what you get. And there is an alternate method for this that not often you see. So you get 9/10 divided by 24/10. You create common denominators. You get 9 over 24, and it just skips a couple of steps. But it's really difficult sometimes to spot and use. So I suggest sticking with keep switch flip. The internal storage of 3 games consoles are 500,000 megabits, 32 gigabytes, and 1 terabyte. Write these in order of size. Okay, so 32 gigabytes is 32,000 megabytes. Okay, so that's 32,000 megabytes. Okay, and then terabytes are 1,000 gigabytes. Okay, so that would be 1,000 gigabytes, which is 1,000 megabytes. All right, so the largest is the 1 terabyte. All right, if you've got a 1 terabyte hard drive, big. All right, 32 gig, not massive. 500,000 megabytes, even though it's megabytes, it's bigger than it sounds. It's just that they've used something that needs to be converted, and those conversions between megabytes and gigabytes and terabytes are new to the to the course, so you do need to really check over those carefully. Next, the diagram shows triangle T drawn on a grid. All right, triangle T is rotated 180 degrees around center 0, 0. Okay, and then the new triangle is rotated 180 degrees around center 0, negative 3 to give the triangle U. Draw the position of the triangle U on the grid. Okay, so we're going to rotate this 180 degrees. So it's going to end up there, there, and then this one will be over here. Okay, so this would be the very first triangle. Normally you'd use tracing paper this. I know how to do it if it's 180 degrees through a different way, which is find that gap, repeat it, find that gap, repeat it. Okay, so this is the midway triangle. This is the one that now needs to be rotated 180 degrees around 0, negative 3. Okay, so find that gap, repeat it, find that gap, repeat it, find that gap. A little bit tricky this time, 4 across, down 2, 4 across. There we end up there. Okay. Now that triangle is U. Draw the position of triangle U. Good. All right. Draw the ring around the type of transformation that maps triangle T onto U. T could get to U just by moving. Okay. Now moving is just translation. Reflection is flipping. Okay. Flipping, it wouldn't be able to flip to produce the same triangle. Rotation is turning. Yes, it rotated, but we need a single transformation that mapped T to U. And enlargement would be, changing size. So it would be translation because it's just moving the shape. All right, next up. The table shows information about the masses of 70 boxes. Great. Draw a ring around the interval that contains the median. Okay, it would be the 35th box. So you've got 70 over 2, it would be the 35th box. Technically the 35.5th, which is a little bit awkward to work with because it's 71 divided by 2. But all we need to know is just keep a cumulative run here. By here we've seen 10, by here we've seen 17, by here we've seen 30, by here we've seen 50, which means that the 35th must be in this group here. Also, these are two really big groups in terms of frequency, so they're going to sort of overpower some smaller ones. So the ring around the correct interval is there, 20 to 22. Draw a frequency polygon to show the information in the table. When you're drawing a frequency polygon, you're going to use the midpoints of each group and then their frequency. So here, this is 15 and then 10. Okay, so this would be 15 and 10. All right. The next one is 17 and 7. Making sure you get halfway between the 8 and the 6. Next one is 19, 13. 19 and 13 there. Okay, 21 and 20. And 23 and 20. Okay, so those are the points. Your frequency polygon is plotted at the midpoint of your class intervals. You should use a ruler to join these up. I don't have one to hand, so there you go. There's my frequency polygon. It's sometimes you see people like joining things up, especially when the frequency polygon might look something like that, and people join it up. You don't need to. Okay, you certainly need to. There's no point. Just join them up with a series of straight lines in between each group. Okay. Next up. The nth term of the sequence is n squared plus 5. Find the 7th term of the sequence. That would be 7 squared plus 5, 49 plus 5 is 54. Easy. Here are the first 5 terms of a different sequence. Find the expression for the nth term of this sequence. So this goes between 3, 5, 7, and 9, which means that it can't possibly be a linear sequence. All right. So more often than not, what it will be, if it's not a linear sequence, a checkpoint, it will be something to do with the quadratic sequence, which is 1, 4, 9, 16, 25. Okay. Now, if we compare 1, 4, 9, 16, 25 to 0, 3, 8, 15, 24, this being n squared, this is n squared subtract 1. Okay. 1 take away 1 is 0, 4 take away 1 is 3, 9 take away 1 is 8, etc., etc. Okay. If it's curved in checkpoint, it will probably be to do with the n squared sequence. All right. Curved, by curved I mean that it's sort of like the gaps aren't even. All right. Find the coordinates of 2 points on the line which have a negative x coordinate and a y coordinate that is a multiple of 4. Okay, so let's try a negative x coordinate and see what happens. Let's try x equals -1. Okay, so when that happens, y equals 5, take away 3, lots of -1. Y equals 5 plus 3, watch out for the two negatives, multiplying together to create positive, and that creates 8. Okay, so that one works. So one of them is -1, 8. Okay, let's try -2. This time we get x equals -2. 5, take away 3, lots of -2, that is 5 plus 6 is 11. It doesn't work. Okay, let's try another. X equals -3. 5, take away 3, lots of -3, that would be 5 plus 9 is 14. It doesn't work. Okay, cool. So these seem to be going up in threes. That's quite interesting. So I think I'm going to skip a couple and I'm going to go for x equals -5, because the next one would be 17 and the next one would be 20. So the next one would be 17. I think when I put -3 and I'll get -17. I get 17. Okay, so 5 take away 3, lots of -5. Okay, so that's going to be 5 plus 15, which is 20, which is a multiple of 4, and there we go. Okay, sometimes you just have to try things out until you find something that works. Okay, there won't always be like a really easy algebra to it. Next up, Chen records the length in millimeters of 10 shells. He draws the stem and leaf diagram. Okay, so there are some errors to his stem and leaf diagram. All right, one thing is that this should be in order. Okay, another thing is that it looks like he's missed something off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, he's got all 10, that's fine. Okay, so he's got 30s, 40s, 30s, 40s, 50s, and 60s. Okay, nothing more than that. All right, so we've got 31, 4, 7, and 8. 31, 4, 7, and 8. Okay, so we have 31, 4, 7, 8. Good. 40, 46, and 47. Fine. Okay, 52, 55, and 68. Okay, draw a correct stem and leaf diagram to show Chen's data. I think I've done it. Okay, it looks fine to me. I can't see any major issues with it. One thing that should be on there also is that you should have a key. 3 line 1 means 31. Okay, get your key on there every single time, no matter what. Even if it doesn't look like there's space for it, just put it on anyway, because you do need a key for a stem and leaf diagram. At GCSE at least, and at Checkpoint you should also have it. All right, next up. The diagram shows the rectangle marked rectangle ABCD, very good. EF is parallel to AB. EG is parallel to HF. Okay, cool. So EF is parallel to AB. EG is parallel to HF. Fine. Calculate the size of the angle marked X. All right, the things that we might want to know first off are, let's check on as many things as we can. Here's a right angle, so that's 70. Great, okay. If this is 46, we could say, well, this will also be this is X here as well. Okay, you've got two vertically opposite angles. Now here it's a little bit difficult to spot, but if I isolate these lines, this line, this line, and this line, what you've got is actually called an alternate angle. Okay, you've got a pair of alternate angles. So the fact that this is 46, this is also 46. Okay, and it turns out that now I've got the angles in a triangle, which is nice. So I can add together 70 plus 46, which is going to be 116, and then subtract that from 180. Okay, which is going to give me 64 degrees for X. Okay, X will be 64. Next, Lily heats the water in her swimming pool. Nice for Lily, lovely. Okay, so the line graph shows, the graph shows the temperature in degrees centigrade of the water for the first 50 minutes after 9 AM. Fine. The water in the container continues to increase at this constant rate. What would happen at 11 AM? Okay, so let's work out how much it went up by in half an hour. Okay, so in 30 minutes, it's gone up by 16.1 to 16.55. So that's 0.55 0.45 degrees C. All right, cool. So if we're talking about the temperature at 11 a.m., that's 30, 60, 90, 120 minutes, okay, because it's 2 hours, okay? So we can just multiply this here by 4, multiply this here by 4, and we're going to end up with 1.8 degrees C increase. Okay, so the temperature will have gone up from 16.1 plus 1.8, okay, and so that'll be 17.9 degrees C. Okay, and you put that down on the dotted line at the bottom. Next, Oliver and Angelique each have a jar that only contains green counters and red counters. Okay, so Oliver's jar, the total number of counters is 42, green to red is 3 to 4. So 3 plus 4 is 7, 42 divided by 7 is 6, 6 3s are 18, and 6 4s are 24. So that's green and red are 18 and 24. Fine. The total number of counters is unknown, but the ratio of green to red is 5 to 2 in Angelique's jar. Angelique has the same number of red counters as Oliver. Well, Oliver had 24 red counters, so Angelique also has 24 red counters. Now, if 2 shares are worth 24, then 1 share must be worth 12. 5 times 12 is 60. Okay, so the total number of counters in Angelique's jar is 60 plus 24, which is 84. Okay, 84 there. Next, the area of the trapezium is 24.5 centimeters squared. Okay, cool. A, B, and H are all greater than 1. Fine. B is greater than A, or A is less than B. That looks about right. Okay, seems fine. The area is 24.5. Find a set, any set of possible values for A, B, and H. Okay, cool. So first off, we need to understand that when you're working out the area of a trapezium, you add together the 2 parallels, divide by 2, and then you multiply by H, and that will equal 24.5, okay, in this case. All right, well, what about if I multiply both sides by 2? I get A plus B multiplied by H, which is equal to 49. Okay, multiplying both sides by 2. Now, they have to be integers. All right, so they've got to be whole numbers. So what if I said, well, the numbers that are going to 49 are 7 times 7? That would be a nice one. So I'm going to go with, or I could go with 49 times 1. But if I did that, H would have to be 1 when it's supposed to be greater than 1. So I'm going to say that this is 7. I'm going to say that these two add up to 7 as well. Okay, so I could say, well, H could be 7 if A and B add up to 7. So I'm going to say 2 and 5, or 3 and 4, or 1 and 6. Any of those is fine. All right, next up. 12 has been divided by 5 subtract 2x, and then that equals negative 3. So the first thing to do is to multiply both sides by 5 subtract 2x. All right, more often than not, you'd think of that as just moving up. All right, expand the brackets. There. Okay, and once you get to that point, you should be able to use maybe a function machine method or something like that. Times 6, take away 15, makes 12. 12 plus 15 is 27, divided by 6. 27 divided by 6 is equal to 4.5. Okay, it might take you a little bit of time to work that one out. For me, I would have got to 9 over 2 by cancelling them down. 9 divided by 2 I know is 4.5, so we've got to get 4.5 out of that one. All right, and the final question. So each bag contains a large number of coloured balls. Each ball is either red or green or blue or yellow. A ball is picked at random from the bag. The table shows some probabilities. Calculate the probability that the ball picked is blue or green. Okay, cool. So first off, these probabilities should always add up to 1. When you add up x and 1.5x, you get 2.5x plus 0.3 plus 0.1, which is 0.4, and those probabilities should add up to 1. 2.5x therefore should equal, take off 0.4 from each side, 0.6. Okay, next, x should equal 0.6 over 2.5. We're going to divide both sides by 2.5, move that under, is what often people think of. That's 6 over 25 when you multiply both sides by 10. Okay, cool. So that is the blue section, 6 over 25. Sometimes people will struggle now because you need to be able to add the fractions and the decimals. This is a little bit easier if you call that over 100. So times by 4 and times by 4, and you get 24 over 100, which is 0.2424 hundredths. Add together the blue and the green, and you will end up with blue 0.24 plus green 0.1, sum 0.34. All right, there's your paper, all done.